We have a nice differentiation problem here. We have a rectangle with two sides x and y. X is the larger side, y is the smaller side, and the relation between x and y is y equals 10 minus x. We have to find the value of maximum area of the rectangle by using differentiation. So given the relation between x and y is y equals 10 minus x, we can give it equation number 1. Then we get the area of the rectangle, a equals xy. We can put the value of y here and we can write x times 10 minus x. We can write 10x minus x square, which is equation number 2. To get the maximum area of the rectangle, we need to differentiate the area A with respect to x. So we get ddx of A equals ddx of the value of A from equation 2, which is 10x minus x square. From here we can write equal ddx of 10x minus ddx of x square. Then we can write ddx of 10x equals 10 minus ddx of x square equals 2x, because from the differentiation rules we know ddx of ax equals a. So from here we get 10, and the next rule is if we get ddx of x to the power n, we can write the result as n x to the power n minus 1. So from this rule we get ddx of x square equals 2x. So the value of ddx of a is 10 minus 2x. We can give it equation number 3. So we need to set the value of ddx of a equals 0 to get the maximum area of the rectangle. So we can write ddx of a equals 0, or we can put the value of ddx of a, which is 10 minus 2x, or we can write 10 minus 2x equals 0, or we can write 10 equals 2x, or we can write x equals 10 by 2, or x equals 5. So we got the value of x equals 5. Now to get the maximum area of the rectangle, we have to put the value of x, which is 5, in the area equation, which is a equals 10x minus x square from equation number 2. So we get maximum area, maximum A equals 10x 10 times 5 minus, we can look at the equation, A equals 10x minus x square. So we wrote 10x and we'll write minus x square, which is 5 square. So we can write 5 times 10 is 50 minus 5 times 5 is 25, or 25. So the maximum area of the rectangle by using differentiation rules is 25. So this is our desired result for the problem. This is the end of the video. Thanks for watching the video.